This is AQA AS Level Maths, Paper 1 2018, so this is the pure and mechanics section. Three of the following points lie in the same straight line. Which point does not lie on this line? I've already ticked the answer. I think I forgot to add that in at the end. But anyway, so if you just say that the line is in the form y equals mx plus c, and so you just pick, say, just pick any 2 points. So if you pick these two, and then you'll just find, say, the gradient. So 14 minus 8, which is 6, and then 6 over minus 1 will just be minus 6. So you can say y equals minus 6x plus c, and then just plug in one of the coordinates to get your y-intercept of 2. Now, if you try that with the other points, you'll see that it doesn't lie on those points. So you think to yourself, oh, well, maybe one of these 2 points must be the wrong one. Okay, so then you'll just pick another 2 points, maybe pick these two instead. Okay, and then say if you did this one, you'd have minus 1 minus minus 6. So you'd have a 5 over 1 minus 2, which is minus 1. So it's minus 5 over 1, so it's just y equals minus 5x plus c. And then you just plug in one of the points in to get this, and then you can just try this with every single one, and you'll find this is the only one that doesn't work. A circle has this equation: find the gradient of the tangent to this circle at the origin. So one way that you can do it is if you just write it out like this. Okay, this is just a cool trick I found out, but say if you have an equation of any circle and you want to find out the tangent at a specific point, in this case the origin, what you can do is you can replace, with origin being 0, 0, you can replace one of the x's from here with the x coordinate of the point that you want to check, and then one of the y coordinates with the y coordinate of the point. So if you're checking 0, 0, you'd plug in one of the x's is 0 and then one of the y's is 0, and then if you just go ahead and put that together, that's the equation of the line which passes through 0, 0 and is a tangent to the circle. So you know that gradient there is 2 over 3. And this works for any case. State the interval for which sine x is decreasing. If you just draw it like this, it's quite obviously between 90 and 270 because it's going down. As you can see, it's got a negative gradient. Find the first 3 terms in the expansion of this. You could use this formula, okay? I didn't, because if you notice here, this is in a form such that you can use this equation. You get this in the equation booklet. So just plug it in. This here should say 2 factorial and then 3 factorial and then etc. Yeah. Anyways, that doesn't matter. You can just imagine it's 2 factorial. I don't know why it says 1.2 and then 1.2 dot 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 r. It doesn't really matter. You should know how to use this. Anyways, just plug in the value where x is minus 3x and then just leave 1 as it is. And then just only pick the first 3 terms. So pick this one, and this one. Just plug it in, expand it, you'll get this. Using your expansion, approximate this to 6 decimal places. So this is our expansion. I think I actually didn't. Sorry, I'm back. I just quickly edited that because I accidentally added another term on for some reason. Anyway, so this was just 1 minus 3x to the power of 4. Almost it, minus the extra terms. And then we're saying we want that to be this, right? So just fall through both sides to get this, and then just rearrange for what x has to be. So it has to be this. And if you plug this into there, because this is not exactly identical to this because we're missing out 2 more terms, but it's close enough so that you'll have a good approximation. So if you plug this into there and then just put that into your calculator, you'll get this to 6 decimal places. Point C has coordinate C2 and D has the coordinate 6D. The line, this is the perpendicular bisector of CD. So if it's bisecting it, it must go halfway across this line, and so the midpoint of it will just be C. The midpoint, so the x coordinate will be C plus 6 divided by 2, and then the y coordinate will be 2 plus D divided by 2, and that's the midpoint. Okay, and if you find the gradient of this line, it'll just be D minus 2 over 6 minus C. You'll have this, but you want the negative reciprocal of it because it's perpendicular. So if you just swap these two around, the denominator and numerator, you'll get this. And then just be careful here, it'll be a C and then it's a minus 6 because it's the negative reciprocal. Anyways, yeah, so this line is just this, and then the gradient is which is this, is just going to be minus 4. So you can set this equal to minus 4. and then if you plug in these 2 points here, that means 2 plus d over 2 is equal to minus 4 multiplied by this plus 11. So you can plug that in. Just to rearrange them both, you'll have simultaneous equations, and then you can just substitute one of them into here. Rearrange, you get d equals 4, and then just plug in d equals 4 into any other one. Maybe this one, you'll get c equals minus 2. ABC is a right angled triangle. D is the point on the hypotenuse such that AD equals AB. So if it's just somewhere roughly here, and that's the point D, okay, and we're saying that the area of triangle ABD, so this triangle here, is half that of ABC, so this full one. If you call this length here X, and then this length here Y, we want to show this by the way, that means this length here is X as well, because AD equals AB. And the area of this full triangle here, sorry, of this triangle here, will be half AB sine C, okay, where this is the angle A. Okay, so half AB sine C is the area of this triangle here, which is just half x squared sine A. Now the area of this full triangle ABC will be double that, because it gives us this information here. So area of ABC is double that, so it's just x squared sine A. Okay, but another formula for another equation for the area of this triangle is half x times y. Okay, so half x times y equals that. If you just multiply by 2 on both sides, you'll get this. And then you'll just think to yourself, okay, well, tan is just the opposite over adjacent. So if you do tan A, that's going to be y over x. Okay, rearrange for y here and then plug it into there. Okay, you'll get this, and then just, obviously cancel the x's to get tan A equals 2 sine A. Show that the equation part A has 2 solutions between this. So tan A equals 2 sine A. This tan, you can just write it as sine over cos. And just don't divide by sine A just yet, because there is a solution here. So if you multiply by cosine A on both sides, you'll see that sine A can actually equal 0. So yeah, you can say that. And then you can cancel it to get this, and then cosine A equals a half. This has a solution at 60 degrees within this range, and this has just 0 degrees because it's an inclusive sign. State the solution which is appropriate is 60 degrees because it's a triangle. Prove that n is a prime number that if n is a prime number greater than 5, it implies that n to the power of 4 has final digit 1. Now this was actually a pretty difficult question, and it took me a while to come up with a good enough solution. Now I'm just going to say that the solution that I'm going to go through here is not the same on the mark scheme. You can read through the mark schemes one, it's much more succinct, and you might even think it's better. It doesn't really matter. This is just the one which I understood more intuitively, but pick whichever one you like. The mark scheme, I'll leave it in the comments if you want to go, in the description if you want to go through it. But so if n to the power of 4 has final digit 1, we can say that n to the power of 4 minus 1 ends in a 0. Okay, so you can say that n to the 4 minus 1 is congruent to 0 modulus 10. So what that means is, if you have this number here and you divide by 10, you'll have the remainder 0. So n to the 4 minus 1 has remainder 0 when divided by 10. You can kind of read it like that. Okay, hopefully that makes sense, because say if you just had some number 150. Okay, so say that this full thing here was 150. 150 divided by 10 has remainder 0, so that's fine. Okay, say if you had 12 here, 12 divided by 10 has remainder 2, right? Because 10 goes into it 2 times, and then you have that other 2 left over. So that 2 left over is just the remainder. Okay, this here, you can factorize this into n squared minus 1, n squared plus 1, obviously leaving the right side the same. And then this here, you can further factorize it because it's a perfect square to get this. Now, n minus 1 and then n plus 1, they're almost consecutive. If you think about it, the only number in between them is just n. So n minus 1, n, and then n plus 1. Okay, we know that n is going to be odd because it's a prime number and all prime numbers are odd. Okay, and that tells us that n minus 1 and n plus 1 are even. Okay, so this full thing here is definitely divisible by 2. Okay, and better yet, it's divisible by 4 as well, because you've got an even number multiplied by another even number. Okay, so these two are both divisible by 2. Okay, hopefully that makes sense to you, because if you have an odd number and you take away 1 from it, it's going to be even. Okay, but also if you add 1 to that number, it'll still be even. Okay, now also if n is a prime number greater than 5, its units place, so the last digit has to either be 1, 3, 7, or 9. Okay, that's just of n. 5 is not included in here. If you might just think about this, it can't be 2, 4, 6, or 8, because that means it's divisible by 2, and then it's no longer prime. And it can't end in a 5, because that would mean it's divisible by 5, and that means it's also not a prime, because the number is also greater than 5. So yeah, it must end in either 1, 3, 7, or 9 for just n, not n to the 4. So n only ends in 1, 3, 7, or 9. Now, if it ends in 1 or 9, if you just go through each of these, if this is the easiest one to like notice. If it ends in a 1 or 9, okay, and you have a look at this one and this one, that means n minus 1 or n plus 1 will have a remainder 0 when divided by 10. If you think about it, say if it ended in a 1, if you have a number that ends in a 1 and you take away that 1, that means it ends in a 0, right? And then that means it must be divisible by 10. For example, say if I had 21, that's not a prime number, but you know, just in this example, say I had 21, and if actually no, we'll pick 41 because that's prime, I think. So say if I had a number 41 which ends in a 1 and is greater than 5 and it's prime, and then I take away 1 from it, I'll get 40, and 40 is divisible by 10 to give me no remainder. And then if say the number was actually ending in a 9, say like I don't know what prime number ends in a 9, 39 maybe. No, not 39. We'll just say 39 for example. You can just pick any other prime number that ends in a 9. Say if it was 39 and then I add 1 to it, okay, n plus 1, so 39 plus 1 is 40, and then 40 divided by 10 gives me remainder 0. So this is true. So this here always ends in a 0, always gives you remainder 0 when divided by 10 for when n ends in a 1 or a 9. Okay, so we've completed half the solution so far. Now what if n ends in a 3 or a 7? Now for units ending in 3 or a 7, you can try this and this, these two here. Okay, and this is the only one that's left that we've not checked. But if we try these ones again, say if it ends in a 3, a number that ends in a 3 take a 1 must end in a 2, so that means it's just even, and so it ends in a 2. That doesn't necessarily tell us that it's going to be divisible by 10. Okay, in fact it's definitely not divisible by 10 if we just have a look at this one here. Now say if it ends in a 3 and then we add 1 to it, that means it ends in a 4. Okay, that tells us that it's divisible by 2. It doesn't tell us that it's divisible by 10 though. So you know, the only other one that we can check is this one here. Okay, so this one here must be divisible by 10 with a remainder 0 for units ending in a 3 or a 7. Now we just have to prove that this is true, and if we prove that it's true for 3 or a 7, that means this is true for 1 or 9, which we've already shown, and then it'll be also true for 3 or 7, which we're about to show just now. Okay, say if n ends in a 3, okay, we can write n as 10k plus 3. Now let me just explain what this is first of all. For a number to end in a 3 and be divisible, for a number to end in a 3, and we're looking at mod 10, it has to be some multiple of 10 plus 3. Right? Just think about it. Any number that has a remainder 3 when divided by 10, so when n is imagine this just as n. When n is congruent to 0 mod 10, sorry, when n is congruent to 3 mod 10, right? We just want it to be some multiple of 10 plus the extra 3 on the end. Okay, hopefully that makes sense. Say if I had n as, say if you want to make 43, that means you'll have 4 lots of 10, so you'll get to 40, and then you'll always have that plus 3 at the end. Okay, so you'll have any multiple of 10, doesn't matter what it is. It could be 12 multiples of 10, 3 multiples, you know, it could be where k is 1, 2, 3, 4, 5, 6. It could be any number for k, but always when you add a 3 to it, it'll always end in a 3. Okay? So this, imagine here this is saying, imagine this 10k was just saying, this number ends in a 0. Okay? 10k is telling us that n ends in a 0, and then we're adding 3 to it, so that means we're saying that n ends in a 3. Hopefully that makes sense. Just think about that for a little bit. Now, if n can be represented as this for when it ends in a 3, we can plug this into here to get this, and then just expand this and then plus 1, so you'll have 100k squared plus 60k plus 9 plus 1, so this plus 10. Okay, now is this divisible by 10? Well, yes it is, because you can factorize at 10 out of this to get 10k 10 lots of 10k squared plus 6k plus 1. So this is divisible by 10 if it's if n and n ends in a 3. Okay, so we've shown this one here now. We just need to show it for for 7 left, for having like 7 left on the end. So that's what we've just shown already. Now, if n ends in a 7, it's just going to be some multiple of 10 plus 7. Okay, so that means we can plug this into here and then expand this the same. You'll get plus 50 at the end. This is definitely divisible by 10 to give remainder 0. Okay, so that is also divisible by 10. So we've shown that if it ends in a 1 or a 9, it's divisible by 10 because of n minus 1 and n plus 1. And if it ends in a 3 or a 7, it's divisible by 10 because of n squared plus 1. Okay, so we've shown it for all ending digits 1, 3, 7, 9. But these are all the ending digits that n can be when n is prime. Okay, so therefore we've shown it for every single possible case. Okay, this is just n to the 4 minus 1, because we went from this into this, so we can go from that back to there. Okay, so we're saying that n to the 4 minus 1 ends in 0 when it's divided by 10. And then if you just add 1 to both sides, we can say that n to the 4 ends in a 1 when divided by 10. So we've said that this is true. So this has final digit 1 always. Therefore, we've proved it by exhaustion. This was really complicated. It is a hard question. The mark team goes over it in a much more succinct way, as I've already said. You know, that might be easier for you, but I just think that this method is a bit more intuitive and it makes more sense. But you know, you just pick and choose whatever you prefer. Question 8. So Maxime measures that's just waffle. We've got this using 4 experiment. We just want to graph it, okay? Just forget all that waffle for now. Find the value of P and V for the data point labeled A on the graph. So if you just look at log base 10 of V, that is minus 0.15. And then if you do 10 to the power of it on both sides, you'll get this. So V equals 0.708. Log base 10 of P, it'll be 2.18. And then do 10 to the power of both sides to get this for P. Calculate the value of each of the constants C and D. Okay, so if we pull out the graph again, okay, and we're saying that it's in this form here, we're going to do log base 10 of both sides, because this graph is in log base 10. So you'll get this. Now, log base 10 of C multiplied by V to the power of D, that's the same as saying log base 10 of C plus log base 10 of V to the power of D. And then because it's to the power of D, we can just bring the power forwards to get this. Now we can just solve this because we know a couple points on it. So say at this point A here, log base 10 of P equals 2.18, and then log base 10 of V is minus 0.15. So just plug that into there. If say you pick this point as well, this next point, then what is it? Log base 10 of P equals 2, and then log base 10 of V equals 0.02, minus 0.02. So plug that into there. You'll get this. Subtract this one from this one to cancel these. Okay, you'll get this, and now it's only in D. You can solve for D to get minus 1.4. Plug this back into any one, say if you pick this one, and then just rearrange for log base 10 of C, and then do 10 to the power of both sides. Just be careful, it's 10 to the power of all of this though, like this, and then you'll get 93.3 for that. Estimate the pressure of the gas when the volume is 2 liters. This is the equation we've just formed with our values plugged in, and 2 here. This here would have been a V, but I plugged in 2 because we want the volume to be 2 liters, and then you get 35.4 kilopascals. Show how the volume minus 5.1 has been calculated. Just imagine, I'm sure you know what all of this is. F of x plus h is just the new y coordinate. That's changed from f of x, and then x plus h is the new x coordinate from h. Okay, you shouldn't have done this when you did differentiation from first principles. I think, yeah, you definitely should have done that. Anyways, to get the gradient, you do the change in y, so it's this, take away this, over change in x, so it's this, take away this, so it'll look like this. X plus h minus x is just h on the bottom. F of x plus h is minus 6.51, and then f of x is minus 6. Minus 6, careful, it's plus 6. And then h is just 0.1. You'll get minus 5.1 from that. Complete the third row of the table. You know, this is kind of common sense. Come on, you know how to do 3 plus 0.01. And then f of x is x minus x squared. It tells us somewhere. Yeah, f of x is x minus x squared. Okay. So then f of x plus h will just be, instead of plugging in an x, you plug in an x plus h, and we already know what x plus h is. Yeah. So yeah, just plug in 3.01. You'll get minus 6.05 for that one there. And so just get the gradient from that. So do change in y over change in x to get minus 5. State the limit suggested by Craig's investigation for the gradient of these chords as h tends to 0. Basically he just wants to find a gradient at a specific point. This will approach minus 5 in his case. So when x equals 3, which is what he's done. So when x equals 3, the gradient just approaches minus 5, because you'll get minus 6 and then minus 5.1, and then you might have between this got minus 5.000001, you know, and then even more decimal places. Eventually it'll just get to minus 5 and stay at that. So it reaches minus 5. Using differentiation from first principles, verify that your result in part C is correct. Okay, so this is just what you need to know. We know that f of x is this, and f of x plus h, we already figured that out last time, but now you just want to expand it to get this. Plug this into there, plug this into there, h, leave it as it is. Careful, this is a minus x and then a minus x squared, so it's a plus x squared. This and this go away. This and this go away. Everything else is just left over. You'll have this. Divide everything by h to get this, and then as h approaches 0, if you plug in h equals 0, then this entire thing just goes away, so it's 1 minus 2x. And then we want it when x equals 3, because that's what we was going through. That's what we were checking last time. So when x equals 3, you get minus 5. A curve has this equation. Prove that the curve has a maximum point at 1, 3. You can write this. This is x to the power of a half, and then this is x to the power of 1. X to the power of 1 multiplied by x to the power of half. You just add in the powers, so it's just 1 plus a half, which is 1.5. In other words, 3 over 2. So yeah, you can just write it like this. Differentiate. This is 4x minus 12x to the half plus 8. And that equals 0, because it'll have stationary points there. Now, you could try and solve this, but I noticed here that you can, this is just a hidden quadratic. You can just say let x to the half equal y, and then just plug that in. So x to the half here, this is y, and then x to the 1 is just y squared. Solve this. I also divided both sides by 4. Solve this to get y equals 2, y equals 1. Thus x equals 4 and x equals 1. We don't want x equals 4, that must be the other solution. And we want when x equals 1. So just plug in x equals 1 into this to find what the solution for y is. So y equals 3. So we've got that coordinate there, y equals, you've got that coordinate 0.13. We've shown that. And now we just want to check that it actually is a maximum. So remember, the second differential gives you the nature of the point. So if you differentiate this again, this is 4 minus 6x to the minus a half. And then this constant goes away. So you have this. Plug in when x equals 1 to get minus 2. That's less than 0, so it's a maximum. Find the coordinates of the other stationary point. Well, the other stationary point was when x equals 4. Plug that into the original curve equation to get what the y coordinate is. You'll get 1. So the point is 4, 1. Plug it into the second differential to get 1. And then that's greater than 0, therefore that point there is a minimum. It's the mechanics section now. So you drop a ball from rest, height of 40 meters above the ground, calculate the speed. We don't have anything to do with time. So you're thinking, oh, this is Suvat. The only Suvat equation that doesn't give us time, that doesn't use time, is this one here. Okay, so we'll use that one. Its initial velocity is 0 because it was held at rest. Its final velocity, we don't know what it is. That's what we're looking for. Its acceleration, be careful. Its acceleration is just 9.8. Because you're not adding any extra force. You're not throwing it down, you're just dropping it. So the only force acting down on it is the acceleration due to gravity, which is 9.8. It kind of gives you a hint up here. and it displaces 40 meters. You get v is 28. It's not going to be minus 28. Just use your head. Object of 5 kilograms moving in a straight. Actually, that was a little bit mean, but you know the reason why it's not that is it's not like moving upwards. It kind of depends on which direction you take to be like positive. Obviously acceleration, because gravity acts down. Okay, so you always assume gravity to be acting down as 9.8. It's kind of just convention. You never really say that it's acting down at minus 9.8. So it always just acts down at 9.8. And even if, no, that wouldn't even be the case here, because you always just want to take the positive solution, because if v squared was equal to a negative number, you can't solve that. That's just not possible. Even in the complex numbers. So this would have to be a positive 9.8. And then here you just kind of have to think to yourself, its velocity is not going to be a negative, because you know it's just, I don't really know how to explain it, but it's just going down. It's not moving upwards, or it's not accelerate. It's not moving in the other direction, in the opposite direction. So it's not moving up, it's moving down. So you just say it's positive, because we said that down was positive with positive 9.8. Object of mass 5 kg is moving in a straight line. It accelerates at 0.6 meters per second. So we've got mass, we've got acceleration. That's ma, so F equals ma. Now, F is the resultant force. Now, F is resisted by some force R. So we can say that the resultant force F is just F minus R. So it's whatever that force is, take away the resistance force. And that equals 5, the mass multiplied by the acceleration, 0.6. You'll get that equals 3. Draw a velocity time graph from this information. So first 4 seconds, it's accelerating at 0.75. So the change in y over change in x is just 3 over 4. So it's just 3 across, 4 up. Oh no, yeah, sorry. Yeah, change in y. I don't know why I went the other way. Yeah, change in y is 3, and then it goes across 4. And then for the next 5 seconds, so up to 9 seconds here, its gradient is just minus 1.2. So it goes across change in y over change in x. So that's just 6 over 5. So you're going down 6, so that'll take you down to minus 3 here. And then you're going across 5. So that gets you to here. Okay. And for the rest of the journey, it just travels 33 meters. We can find some other stuff, like the time traveled in that distance, the time taken to travel that distance, using velocity equals displacement over time, because this is a velocity time graph. Now the velocity is just 3. Okay. It's just 3. You could plug in a minus 3 and then just think to yourself, and then get a negative time, and then just think to yourself, oh, it's going to be positive, so just take the absolute value. But anyways, so the velocity is 3 here, okay, and its displacement that it's traveling across is going to be 33 meters. I rearranged to get t, which is 11. So for for the next 11 seconds it stays at this velocity of minus 3. So that's up to there. Find the distance of the car from P after 20 seconds. So after 20 seconds, remember, just remember that the distance is just the area under the graph. If you do half base times height, this is a triangle here. That's 4 multiplied by 3, which is 12. Half it to get 6. This one here, this is 3 multiplied by 2.5, so 5 over 2. 5 over 2 multiplied by 3 is 15 over 4. So that's that there, because you multiply by half. You would have had 15 over 2, but 15 over 2 multiplied by half is 15 over 4. This triangle here are the exact same, so this is also 15 over 4. And then this one here is just 11 across and then 3 up, so that's 33. This area is under the graph, this area is under the graph, so these are actually minuses. Okay, so you have 6 plus 15 over 4 minus this, minus that. These two cancel, so it's just 6 minus 33, which is minus 27. So it displaces minus 27 meters, but its distance is just a positive. You always just take positive, because distance is a scalar, not it is a scalar, not a vector. we've got this situation here. These are both held at rest 1.5 meters above the ground. They're released, and we want to find the time taken for this one here to reach the ground. Okay, so if we just draw on the forces acting here, we've got a mass of 1.2 kilograms, and now its weight is going to be mass times by gravity. So 1.2 is its mass multiplied by gravity, which is 9.81. Just put that in. That's going to be 1.2 multiplied by g, where g is 9.81. I'm just going to write g here, just because I don't want to be writing a bunch of decimal places. So we'll just say this is 1.2 g, and then this here similarly is 1.8 g. Okay, and there'll be tension in this rope, in this string here, and it's going to be equal on both sides. You should know this. Now, if you look at this part here, this particle, we'll call it particle A, it's going to be moving down, so there's a resultant force acting downwards. So we can say that the net force is 1.8 g take away t. So it's this 1.8 g force take away that resistance force acting against it. So it's 1.8 g take away t, and that equals its mass 1.8 multiplied by the acceleration a. We don't know what the acceleration is, so we'll just leave it as a. And then we'll do the same thing for this one here. Now, you don't do 1.2 g take away t, because this has a resultant force going upwards, right? So t is going to be greater than 1.2 g. So it's t take away 1.2 g equals its mass multiplied by acceleration. They'll have the same acceleration because they're both connected. So you can rearrange for a here and plug it into there. I didn't bother. Instead, I just added both of these because we can cancel the t's and then solve for acceleration, where g is 9.8. I did write 9.8, but to be honest, I should have wrote 9.81 because that's what it tells me to do. Anyways, I got a is 1.96. You do get the same answer, by the way. I might have dropped them out for that. It doesn't really matter. Anyways, using SUVAT now because we're looking for time, and we've got the constant acceleration of 1.96. Which one are we going to be using now? Let's go through this. We're not going to use this one because this one has this one doesn't even have time in it, so that's just not going to be helpful. Do we have the initial velocity? Yes, we do. It's 0 because they were both held at rest. We don't have the final velocity, so anything that has any of these equations which has a final velocity in it, we're not going to use it. So we're not going to use this one because it has no time and it has final velocity. Not going to use this one because that's final velocity. Same with this one. Same with this one. This is the only one that doesn't have it, so we'll use this one. U is 0. The displacement is 1.5 meters. Acceleration is 1.96, and we're looking for t, so just solve to get 1.24 seconds. State one assumption you have made in answering part A. It's what I wrote is that the string is long enough such that the 1.2 kg mass doesn't hit the pulley, because say as this is moving down, say if it gets to here but this has already hit the pulley, it's going to be restricted so it can't move down any further. So we've assumed that this actually is long enough such that this can come down and hit the ground. A cyclist is traveling in a straight line, constant speed of this. Now this other rider Jason is behind Laura, okay, and we're saying that his driving force is probably less than hers. And that makes sense because if Laura is in front of him, she's going to be shielding him from air resistance, so he'd need to apply less force to be traveling this same at the same speed. Okay, so you can just say that he's like guiding her, or you can say slipstreaming. So Jason is affected by less air resistance as he's behind Laura. Okay, so he's slipstreaming behind her. Yeah. Jason has a problem and stops. This has literally no use in this in answering this question. She sees an accident 40 meters ahead, stops pedaling, applies brakes. Total resistance force of 40 newtons, and she's got a mass of 64 kg. Determine whether Laura stops before reaching the accident. If we imagine this box here is just Laura, okay, and she's got a resistance force of 40 newtons, and she's got a mass of 64 kg. Now, her net resistance force is just this minus 40, because if we take this this direction here to the right to be positive, then this will be minus 40 as her net resultant force, or just net force, equals her mass 64 multiplied by acceleration, which is just a. Solve for a to get this. It does make sense it's minus because she's slowing down, so yeah. Now we want What was this? Determine the lowest. We're going to be using Subet now. Because this is constant acceleration. Okay, and it says constant speed as well. Now we're just going to have to determine which one of these we're going to be using. There's, first of all, let's just write down some values. Do we know U? Yes, we do know the initial velocity. I actually told us earlier on. It was 24 kilometers per hour. That is just that's just 25,000 meters per 3,600 seconds, which is just 6.94 recurring meters per second. Okay, and then let's see. So we have the final velocity. Her final velocity is going to be 0 because she's stopping. Her initial velocity we know. We know that the distance she wants to travel. Oh no, we don't know the distance that she is going to travel because we're saying it's hopefully less than 40, so she doesn't actually have an accident. And we know her acceleration. So we know this, and we know acceleration, but we don't know distance or displacement. So we'll look for it. So we're going to be using this equation here. Solve for s to get 38.6. This is less than 40 meters, so she actually stops 1.4 meters before the accident. So yes, she stops in time. Set one assumption you've made that could affect your answer to part A. It's that the 40 Newton resistance force is actually constant. Because if she maybe she was applying a brake on the, maybe she was braking, but she wasn't applying the full force. So she might have only started off at 40 newtons and then was like, wait a minute, I might actually not reach it in time, and then push down even and then crunched her hands even further onto the brake to increase the force, because then that would mean that she's stopping sooner. Or she might have pulled back to start braking at 40 newtons and then released it a tiny bit for whatever reason, so she's got a less resistant force, and then would have actually not made it in time, not stopped in time. Anyway, so yeah, you can say that. We've got this is not constant acceleration. You might just recognize from the way that this question looks that these questions like this always just want you to be integrating or differentiating or something like that. Anyways, we're just going to integrate. We're looking for the displacement r. Okay, and we've got the velocity. So if you integrate velocity, you'll have displacement, as you do it with respect to time. So just integrate this. This is 0.06 times 2, so 0.12. And then yeah, I've just distributed the 0.06. You know how to do that. This goes to 0.12 t, and then this is 0.06 multiplied by a half, so 0.03 t squared, and then this is a third 0.06, so just 0.02 t cubed plus c. The initial displacement is 3 meters, so c equals 3. You could just plug in t equals 0 and then to get r equals 3, so that's to get c equals 3, so that's fine. Anyways, r equals this, and that's your answer. At time t equals 2, the toy launches a ball which travels directly upwards with initial speed 3.43. Find the time taken for the ball to reach its highest point. Now, we're going to use Suva again, okay, because we're doing time and initial speed and stuff like that. So, we're just going to have to think, well, which one of these are we going to use? When it's reached its highest point, if you think about it, if you throw a ball up, it'll stop for a very brief moment as it's turning around. And as it's turning there, its final velocity is just 0. So v is equal to 0, and its initial speed is 3.43, so we know what u is. And its acceleration is kind of giving us a hint there that we're going to be using that. So the acceleration is just gravity backed in the opposite direction, and its time, well, that's what we're looking for. Okay, so instead of gravity acting down 9.18, it's acting it's acting minus 9.8 because it's upward. So when you're throwing the ball upwards, it's acting against gravity, with a force minus 9.8 newtons per kilogram, or you could say meters per second squared. Anyways, yeah, rearrange t to get 0.35 seconds, and that's it. Thank you for watching. That's everything.